All right, just like the first example, we're going to first look at the graph so we kind of know what we're aiming for, and then we're going to show you how to analytically come up with global max and global min for another example. All right, so I'm going to pause and draw my graph in. You do the same. All right, so you got your graph, and it should look like some kind of right-sided parabola that actually has vertical asymptotes on it. Now, if you graph this on your calculator and you didn't zoom in or zoom out a little bit to get a little bit more knowledge on this, you probably thought it looked like a right side up, like a cupping upwards semicircle, but it's not. Okay, so be careful. And I knew, because of my knowledge of math, that this bottom right here factors into 2 minus x and 2 plus x. And we know that if you have factors on the bottom that don't cancel on the top, that those are vertical asymptotes. So I knew x equals 2 and negative 2 were vertical asymptotes, so I knew that it was getting closer and closer to that. So that's how I kind of knew that ahead of time. So if I'm just looking at this graph, there's no global max because it never ever hits any number that's highest. It keeps increasing without bound. However, there is a global min. It happens right here. We'd have to actually figure out the value. That's the global min. And we're going to do that analytically. So remember, there are 3 ways to find critical points, and those are the places that might be the global max and min. One of them has to be the global max and min if there is one, but you have to do these 3 things. First, you have to say f prime is equal to 0. You also have to find out where f prime does not exist, and you have to find out the values at endpoints if there are any. So first of all, f prime equals 0. Well, remember that this guy is really 4 minus x squared to the negative 1/2 power. That's a negative 1/2 power, okay? So because it's on the bottom and it's a square root. Square root's a half power, but to make it not be on the bottom, I change it to negative half. Now you could do quotient rule if you like. I don't want to do it, it's just extra work. So f prime equals, it will be, bring down the 1/2, negative 1/2 actually, leave everything else alone, except subtract 1 off. If I subtract 1 off of the exponent, 1/2, negative 1/2, negative 1/2 minus 1 is negative 1/2 or negative 3/2. All right, now I have to go inside and take the derivative. Well, the derivative inside is negative 2x. All right, so I need to know where that equals 0. Well, it's where each of the factors equals 0, right? So it's where this equals 0 or where this equals 0, right? So each of the factors is a possibility where it equals 0. That's a 3. Okay, so this really is a negative exponent, and I missed my squared, so I'm going to add it in right there. There's a squared I missed. So I'm going to go ahead and change that negative exponent to a positive by moving it down. Okay, so now I'm going to think of a fraction as cross-multiplying to see what it is. So I get 1 equals, well, this guy times 0, because when I cross-multiply, equals 0. So there are no solutions there. Okay, so that doesn't give us any critical points. But this one does. X equals 0. So there's 1 critical point there. Hey, that's the global min that we said from our graph. So we kind of knew ahead of time we were aiming for that. So what about where f prime does not exist? Well, the only place where f prime would not exist is where the bottom of the derivative equals 0. Well, this is really the bottom of the derivative, right? Because it's a negative exponent. So we really need to look at the bottom and find out where it equals 0, right? Well, where does the bottom equal 0? Well, let's solve it. So I'm going to raise this whole thing to the 2/3 power to cancel this. Well, if I do 2/3 power over here, I still get 0. I have 4 minus x squared equals 0. So I have 4 equals x squared. So in other words, x equals plus or minus 2, because remember, when you square root, you get 2 possible answers. So that is where f prime does not exist. Well, that's because there is a discontinuity, right? No derivative where there are discontinuities. Okay. So that's kind of the graphical reason. And the third reason is where we have endpoints. Well, this function doesn't have endpoints, so there are none, okay? It just doesn't have any. It does kind of stop in that it never goes past -2 or +2, but it never ends either. So there's not a place where there's a removable discontinuity, like a hole or a endpoint. It just doesn't have them. So there are 3 critical points: 0, -2, and +2. So we have to go to our original function and put in 0, and then we get 1 over 4 minus 0 squared, square root of that. So we have to do 1 over square root of 4. I get a half. All right, so that's our global min right there, by the way. But let's just test. If I do f of 2, I get 1 over 0. We know that 1 over 0, if we take the limit, it's going to infinity or negative infinity, but we're going to cheat and use our graph. And actually the same thing happens. It does not exist, by the way. There's no value there, right? So 1 divided by 0, that's another way to say it. So f of -2, also 1 over 0, it does not exist. Okay, so d(any). So the only one that exists is this guy. You kind of have to know that it's increasing. We'll talk more about that later on how you know for sure that it's increasing, and then that's from in both directions from 0. But we're looking at the graph right now to say this is our global min, 1/2 is the lowest value, everything else is higher. We know that it's going to infinity. We have to check like the limits to know that it's going to infinity, not negative infinity. So that's a review kind of thing.